Welcome to Everything Explained. Today on the show, we're peeling back the curtain on a question you hear a lot. How does an algorithm decide what you see online? It's not random. It's a careful blend of signals, goals, and a lot of math, wrapped in a user-friendly interface. Every time you refresh your feed or type a query, a team of engineers is running tiny experiments that try to predict what you'll click next, how long you'll stay, and what you'll come back for. The result is a personalized stream that often feels tailor-made, but it's also the product of design choices and data collection. By the end of this episode, you'll understand the basic idea behind these engines, and you'll have some practical ideas to navigate them more thoughtfully. Let's start with a simple picture. An algorithm, in this context, is like a recipe. You take ingredients, your past actions, the content in front of you, the time and place you're using the platform, and you mix them through steps. Rules that assign scores and a way to order items. The goal isn't just to show you the most entertaining thing, it's to keep you engaged, to help you discover something new, to fit an advertiser's goals, or to push you toward content that the platform believes you'll value. The exact recipe changes from platform to platform, but the basic idea is the same. Turn data into a ranked list of what you should see next. So where do these ingredients come from? Signals. Think of signals as clues about what you like and what you're doing. They include your actions, what you clicked, how long you watched, whether you liked, shared, or saved something. Content signals, what the piece is about, what format it's in, video, text, image, how fresh it is. Context, the device you're on, your location, the time of day, the language you use. Platform signals, how other people reacted to the same content, how new the post is, whether it's part of a trend or a breaking story. Weighing short-term versus long-term goals. A video that grabs attention now might be deprioritized if it performs poorly later, and vice versa. How does the ranking actually work? Each item you could see gets a score, a prediction of how likely you are to engage with it. The higher the score, the higher it appears in your feed. These scores come from models trained on vast amounts of data. They learn to estimate probabilities. Will you click? Will you watch to the end? Will you drop out quickly? And then translate those probabilities into a ranking. A big part of this is feedback. When you click on something, the system sees that as a green light and might show you more like it. If you skip or quickly scroll away, the system may cut back on similar content. It's a loop. Your behavior shapes the model shapes what's shown, and what you see then influences your next choices. This is where the exploration versus exploitation tension shows up. Do you show more of what you already know you like? Exploitation? Or do you sprinkle in unfamiliar items to learn new preferences? Exploration. Platforms tilt toward exploitation most of the time because it keeps you more engaged, but they do dip into exploration to prevent stagnation. You'll see these ideas in action in a few familiar places. On YouTube, the homepage and the up next recommendations build from your watched history, your surface time, and your reaction patterns. A seasoned YouTuber might notice the system nudging you toward long, bingeable sessions, sometimes at the expense of shorter, diverse content. On Facebook or Instagram, the feed is tuned to surface posts from people you engage with most, mixed with suggested content that feels relevant based on your past behavior and relationships. In search, the engine aims to balance relevance to your query with trustworthiness and freshness, sometimes personalizing results based on your history. There are real-world consequences to this design. The feed can create echo chambers, where you mostly see content that confirms your views. It can prioritize sensationalism if that drives clicks, even if the material isn't the most reliable. It also raises privacy questions. To tailor feeds, platforms collect details about your habits, sometimes across apps and sites. And because the system learns from your actions, a small change in behavior can shift what you're shown in ways you might not anticipate. What can you do to stay a bit more in control? Here are practical moves. Be aware of the signals you're feeding the system. Your early reactions to a post have outsized influence. Diversify your sources. Actively seek content outside your normal bubble and engage with it in a deliberate, reflective way. Use built-in controls. Many platforms let you view or reset your interest signals, or switch off certain kinds of personalization. Check what you're following and why. If you notice a pattern you don't like, look for options to refine or reduce its influence. Try incognito or private modes for initial explorations of topics you want to understand without the system learning from those first interactions. In a sense, these algorithms are invisible librarians. quietly ranking shelves full of books and showing you the ones they think you'll choose. They're powerful, and they shape how you learn, how you entertain yourself, and even how you understand the world. But they're not omniscient. They're approximations built on imperfect data and imperfect objectives. The more you know about how they work, the more you can steer your own online experience toward what you value. So, to wrap up, your online world is curated by a machine that scores, ranks, and recommends based on signals drawn from your behavior and its goals. It's a dynamic, feedback-driven process that can both reveal new things and trap you in a familiar loop. Understanding the basics helps you see through the haze and, when needed, take back a bit of control. If you want to see clearly what determines your feed, start by asking, what signals is this platform using, and how are they shaping what I'm shown? The answers won't always be simple, but they're worth chasing.